Microsoft Azure storage accounts represent enterprise cloud storage, and it gets deployed as its own resource. That means it's an object that you deploy within your Azure subscription. You need a subscription to deploy anything, including storage accounts. Now, you're not limited to using one. You can have a multitude of storage accounts perhaps deployed in the same region, in different regions, with different administrative teams that have access, or maybe you'll have a storage account deployed in the back end that's used by a front-end web application. There are many uses for storage accounts, and there are also many different types of things you can store within them. The first type of thing we can store in a storage account is a binary large object or a blob. Really, all this means is that you're storing files in the storage account, whether they are uploaded from on-premises or they are a result of some code running in a front-end web app. A blob is essentially a file stored in the cloud. The next type of thing you can configure in a storage account is a file share. Think of this as really just being a shared folder definition that exists in cloud. And so its definition and its files are part of the storage account. And you can map drive letters to it, just like you would with any type of normal on-premises shared folder, or in the case of Unix and Linux machines, you can set up a remote mount point to connect to that shared location. You can also create message queues or storage queues in a storage account. That's going to be of interest for developers, and we'll talk about that in a moment further. And finally, you also have basic key and value pair table storage. Let's jump into some details related to blobs within the storage account. So we know that this is simply cloud-based file storage. Within the storage account, you can create one or more blob containers. Think of these as simply being like folders on a disk to organize related files. You can do the same kind of thing and create a folder hierarchy or a blob container hierarchy within your storage account. Each blob is defined as being stored in a particular storage tier, such as the hot storage tier, which is designed to be used for frequently accessed files. The idea is that the underlying storage is using solid-state drives or SSDs, as compared to cool storage. The cool storage tier is less expensive than hot, but it also uses magnetic hard disks, which are slower than SSDs, under the hood. Then you've got the archive storage tier. When you archive a blob, it's designed to be kept in an archive state for at least 180 days. It doesn't have to be, but you will incur a charge if you don't wait that long if you try to rehydrate it. The way it works is that when you archive a blob, it still shows up in the storage account, but if you try to access the contents of the file, the contents are inaccessible because they've been archived for the long term. And so the rehydration process then is used to get that data back in an online state so you can actually access it. And that might take from a few minutes to a few hours. When you're rehydrating, you have the option of specifying a higher priority to get it back quicker, which means you're paying a premium. So you can switch the blob storage tier at any point in time using command line tools or using GUI tools, including the portal. You can also configure lifecycle management rules to automatically move blobs into the appropriate storage tier. For instance, if blobs haven't been modified in a certain number of days, you can have them deleted, you can have them moved to the cool access tier or the archive tier. You can enable blob public access. The default is private. Public access could be applicable if, for example, you've got files or blobs in the storage account that are going to be served up on a public-facing website that doesn't require authentication. You can also enable blob versioning so that when you modify a blob, the newly saved modification becomes the current version, but it saves the previous version. You can also create snapshots of blobs, which are similar to versioning, except they're not automatic. A snapshot is a point-in-time picture of the state of the content of the blob at a certain point in time. You can also enable soft delete so that when you delete blobs, you can restore them within a configured time period before they're permanently purged or removed from the storage account. There are three types of blobs. The first is a block blob, and that's the most common type you'll see used for standard files that are uploaded into a storage account. Page blobs are designed for random read and write access to large files like virtual machine hard disk files. And then we have append blobs, which are normally used for files to keep writing to the end, such as with log files. We mentioned that storage account file shares are like shared folders in the cloud. So from a Windows perspective in this example, the shared folder is accessible either from an on-premises machine or from virtual machines in the cloud over TCP port 445. So if you're mapping from a Windows machine, the OS needs to support at least Server Message Blocker SMB version 3.0. So you can make drive mappings, or you can use mount points to connect to that over the network. Windows, as well as Unix and Linux, support mount points. Of course, in Unix and Linux, we don't have the notion of using drive letters to map to a remote network location. We solely have the option of mount points. We mentioned that storage account queues would be of interest to software developers. In this diagram on the left, we have app component 1, where it would drop a message into a queue in the storage account. Now, a second app component 2 on the right of our diagram, would then be able to read that message from the queue when it's available. Meaning that if app component 2 is busy, when app 1 needs to communicate with it, it's not a problem. There's no dependency on all these components being up and available on the network at the same time, because we have a storage queue to store messages that can be processed when needed. Finally, we can have storage account tables stored within a storage account. This is a simple NoSQL-based type of storage, so that means it's an unstructured schema or definition of what will be stored, and it's designed to store simple key and value pairs. Now, there are many different storage account settings that you can configure either during storage account creation or after the fact, some of which include access keys. Every storage account gets 2 access keys and 2 connection strings. And you can hand out the connection string or the access key, any one of them, to anybody that would need full access to the contents of the storage account. And that way they wouldn't need an Azure AD user account to sign in with. They could just use the access key or the connection string. The reason you get 2 of them with the storage account is so that one can remain active while you regenerate or rotate the second key, which you should do periodically for security reasons, in case the key's been compromised in the past. You can generate a shared access signature for the storage account, which allows limited access, for example, perhaps only to read blobs for a certain period of time in the storage account. Although you can also generate a shared access signature for an individual blob in the storage account. Encryption is enabled by default for protection of rest in your storage account, but what happens is Microsoft managed keys are used. Due to laws, regulations, or contractual obligations, you might have to have sole control of encryption keys, and you can do that, but that is not the default setting. You can also enable geo-replication, so you have a secondary copy of the storage account in a secondary region. So that means that if there's an interruption of some kind in the primary region, you can't get to the storage account there, you could get to it in a secondary region. Depending on how you configure geo-replication, you might have to enable failover even to read the secondary copy. Either way, you'll have to enable failover to the secondary copy if you want to write to that part of the storage account. In this demonstration, I'll be creating a storage account using the Azure portal. Now, a storage account really represents enterprise storage in the Microsoft Azure cloud, and it can contain numerous items. It can contain binary large objects or blobs. In other words, files that you might otherwise store on a USB thumb drive or on a hard disk inside a server. Instead, we can upload those as blobs in a storage account. Storage accounts can also support file shares, in other words, shared folders. They support message queues, which software developers are interested in for transmitting messages between software components, and also basic key-value table-based storage. So let's get started with creating a storage account. So here in the portal, I'll start by clicking Create a Resource. I could navigate through the categories, or I could just type in what I'm searching for, in this case, storage account. So I'll select that from the list, and I'll choose Create. As is always the case with IT, we don't just randomly start configuring things. We have to think carefully about how the service will be used. For instance, we're creating a storage account, but you might ask yourself, well, wait a moment, in a larger enterprise, how many storage accounts should I have? Where should they be located? What type of data will be stored in them? All of these things are careful considerations, along with the naming conventions. You don't have random nomenclature for any of your resources in the cloud, including storage accounts. So as an Azure administrator, planning is key as well ahead of time, which leads us to the implementation where we are now. So I'm going to put this in a subscription. I have a pay-as-you-go subscription, and I'm going to create a new resource group called HQ for headquarters. And I'll click OK. So the storage account name, first of all, cannot contain uppercase letters. So when I do that, it states that it can only contain lowercase letters and numbers, and it's got to be between 3 and 24 characters long. No problem. So I'm going to call this store account HQ1. I'm going to have it created in the East US region under the assumption that most of the access to the contents of that storage account will come from that area, although we could replicate the storage account to an alternate region as well. I'm going to leave the performance setting on standard. You could select premium at a higher cost, but that would give you reduced latency, so the best possible performance at the disk I/O level. Redundancy here is set to geo-redundant storage or GRS, which will replicate the data to a secondary region in case there's an interruption in the primary region, but we could change that if we really wanted to, for example, to locally redundant storage or LRS, where you have redundant protection at least against failures within a data center. However, I'll leave it on geo-redundant storage and I'll click next. We then have miscellaneous options, such as whether or not we want to allow public access to blobs. An example of when you would do that is if you're using the storage account to back a public website where there would be public files, for instance, for people to download, like product documentation that should be freely available to anybody, and of course the files that perhaps comprise the website itself, depending on what solution you're using to host your website. Then whether we want to allow storage account keys, 2 of which are created automatically for each storage account, if we want to allow access using those keys, among many other options. I'll click next for networking. The default is that the storage account can be connected to from any network, so it's set to public endpoint, all networks, which also includes the internet. We could change that, but I'll leave it that way for now. I'll click next for data protection, where we can do things like enable soft delete for blobs. So in other words, if we delete files in the storage account, they are retained for a default of 7 days, where you can restore or undelete them, after which they are purged. You can do the same for containers and for file shares. I'll leave all the defaults for that. I'll click next for encryption. So protection for data at rest in storage account is enabled by default using Microsoft managed keys. Now for regulatory or legal reasons, you might have to use customer managed keys solely under your control. But for now, we'll leave it on Microsoft managed keys. I'll click next. We can add up to 50 tags, so name and value pairs. I'll skip that. I'll just click next to review and create, and I'll click create to get this storage account created. Okay, so our storage account is now deployed. We can open up our left-hand navigator and go to the storage accounts view. Among other existing storage accounts, I've got the new one we just created, store account HQ1, and from here we see it's been deployed to the HQ resource group in the East US location or region. Now another reason you might create additional storage accounts is for administrative purposes, where you can set role permissions for one set of admins to manage one storage account and a different set of admins to manage a different storage account. In this case, I'm going to click on our newly created storage account to open up its properties. And you can make a lot of changes to its configuration after it's been created. Over on the left, if I scroll all the way down, under settings, I can click configuration, and I can change things that we saw upon the creation, such as whether blob public access is enabled or not, whether storage account key access is enabled or not. Now on the topic of keys actually, let's scroll up on the left and under security and networking, let's click access keys. Every storage account gets 2 keys and 2 connection strings. Here they're labeled as key 1 and key 2. Now up at the top I've got a button where I can show the value of those keys and connection strings. What is this for? Well, you can provide the key or a connection string, either one, to those that need full access to everything in the storage account. That way they wouldn't need an Azure AD account to sign in with. So whether they need programmatic access, whether they're going to use a tool like the free Microsoft Azure Storage Explorer GUI tool to connect to the storage account, they can connect without an account by using the key or the connection string. In the security world, it's a good idea to periodically change the keys or rotate them. That's why we've got a rotate key button for both of them. So let's say I decided to rotate key 1. Well, key 2, whether it's the key or the connection string I've handed out, will still be valid to access the storage account. But after I rotate key 1, those that had the old version of key 1 cannot access the storage account anymore until I give them the newly generated key or connection string. It's kind of like periodically changing the keys or locks for doors in-house, especially, for example, if you purchase a new property. You probably want to have a locksmith change the keys and the locks, just in case there are some unsavory characters that might have the old keys. We don't want those to work anymore. The same idea applies here. Over on the left, if I were to click under data management, geo-replication, remember that was enabled by default when we left it? So while we created our storage account in the East US region, it automatically created a replica in the West US region, a secondary copy. Now, if for some reason the primary version of the storage account and its contents in the East US region are unavailable, I can enable failover to the secondary region so that it can be used instead. If I scroll up a bit on the left, under data storage, I can go to containers. These are blob containers where I can add blob containers, or it's kind of like a folder on a disk. And then ultimately, once I'm in one of these blob containers, I can upload blob files, such as files I might have on premises. However, I'm going to click the X to close out of that container. I can also go into file shares to create shared folders here in the cloud, just like you might create a shared folder on an on-premises file server. We can create message queues that software developers can write their code to write messages to or read messages from. And we can use basic key value table storage. So in a nutshell, that's how you go about creating a storage account using the portal. Binary large object, or a blob, is a file. So when we want to store blobs in a storage account in the Azure cloud, what we're talking about is storing files, whether they're spreadsheets, whether they're virtual machine hard disk files, whether they're log files, whatever type of file it is. So that's all we're really referring to. Now there are different types of blobs, and we'll get into that shortly. Let's start by, first of all, here in the portal, opening up our left-hand navigator and going to the storage accounts view. What I want to do is open an existing storage account so that I can upload blobs to it. I'm going to select a storage account of interest, and I'm going to click under data storage on the left on containers. Now a blob container is really just a folder, the same way you would create a folder or a directory on a disk to organize related files. Now I already have a blob container here called $logs, which of course will be used to store logs, but I'm going to create a new blob container by clicking the container button up at the top. I'm going to call this projects. The default access level is private. In other words, no anonymous access. If I were to choose blob anonymous read access for blobs only, it would allow people that haven't authenticated to Azure to read individual blobs given that they know the URL pointing to that blob. Or we could do the same type of thing, but instead for a container that might contain many blobs. And if you're using this to store public files that should be available, let's say to a website, then it might be okay to use anonymous access for blobs or containers. But I'll leave it on the default of private, and I can change that at any point in time. And then I'll click create. So we've now got a project's blob container. If I put a checkmark to select that container, I can click change access level at the top, and this is where you would change it, for example, to public blob or public container access. However, I'm going to cancel that. Of course, we could delete the blob container, but what I'm going to do is click on it to open it up. Of course, it's empty, but what I'm going to do is click the upload button, where I can then select files such as from my on-premises computer that I want to upload into the cloud. And that's exactly what I'm going to do here. So I've selected a couple of project files. I could choose to overwrite them if they already exist in this blob container. And under advanced, the authentication type here is a storage account access key. I'm going to leave that default. But we could authenticate using an Azure AD user account. The default blob type is a block blob, which is fine for smaller standard files. But if we've got a large virtual machine hard disk file, which is a large file with random reads and writes throughout the file, we're better off storing this as a page blob. If it's a file that keeps getting added to at the end of the file, such as a log file, then we could flag this as being an append blob. I'll just leave it on block blob. The access tier determines what type of underlying disk storage is used, whether it's slow magnetic hard disks, which would be the cool access tier, or the hot access tier, which uses solid state drive back storage, or you could archive the item. Inferred means that it's picking up the default storage account setting for the access tier, which is hot. That's all that means. I could also add key and value pairs or tags for each uploaded file. I'm just going to leave that alone, and down at the bottom, I'm just going to click upload. So because they're small files, we're going to upload in a hurry. So the files now show up here in the blob container. So we have the name of the file, the creation date and timestamp. Of course, if they get modified, that will be updated as well. The access tier, which is hot inferred, they're not archived, and the blob type is block blob. Of course, we have the size of the file bytes shown over here on the right as well. Now, I could put a check mark to the left of one of these uploaded blobs, and I could choose to delete it. I could change the storage tier. It's set to hot inferred currently, but if I decided this should be archived for infrequent use, I could choose archive, for example. If I need exclusive access to this selected blob, in other words, I don't want any other processes or users reading or writing to it, I could acquire a lease on it. I could also click the three-dot menu button to view snapshots or take snapshots or point-in-time pictures of that file. If I click directly on the name of that blob or that file, it pulls up all the properties, including the URL, to directly access that file. So if that, for example, is a company logo graphic image that should be referenced on a web page, this is how we can get the URL pointer to it. I can also download this blob to my on-premises computer. We can view versions of it if versioning is enabled, snapshots if we've taken snapshots. The primary difference being that versions are automatic. Whenever you make a change to the file here in the cloud, it creates a new version of the file. Depending on the file type, you might actually be able to edit it right here. Because it's a TXT text file, we can edit it right here in the editor. And finally, you can generate a shared access signature or a SAS, which gives potentially time-limited restricted access to this one and only blob in the storage account, as opposed to a storage account access key, which would give full access to the entire storage account contents. So that's how you can start to populate your storage account with blob containers and ultimately blobs. You can use PowerShell to upload blobs into an Azure storage account. Of course, you can also do that with the CLI, you can do it programmatically through API calls, and of course, using the Azure Portal GUI, which we have open here. Now to get started, I'm going to open up Cloud Shell. Now when you're using Cloud Shell, it in the background uses a storage account that was created the first time Cloud Shell was launched. For example, if I just minimize Cloud Shell and in the portal in our navigator on the left, let's say we went to the storage accounts view. So I have a Cloud Shell storage account here that is used when you are launching Cloud Shell to store files persistently between Cloud Shell sessions. And the reason I'm telling you this is that because if you're going to be uploading files from within Cloud Shell to a storage account, those files have to be available here in Cloud Shell. So if I were to run CLS for clear screen and then dir for directory, any files that are currently here in the cloud drive, as it's called, will be shown. So what do we do then if we have files on premises that we want to upload into a storage account? Well, one option is to download and install and then run Azure PowerShell commandlets on your on-premises computer. The second option is to do what we're doing here, run Cloud Shell, but then what you would do is click the Upload Download Files button to get your files from on-premises into Cloud Shell, the Cloud Shell storage account. Then you could upload them into your storage account. So I'm going to click the Upload Download Files button, and I'm going to choose Upload, and I'm going to upload a sample file. It won't be long before it says it's complete because it's a small file, so if I do a dir, it's there, it's called budget1.txt. So what I'm going to do is I'm going to use PowerShell to upload that file into a storage account. First thing I should do is run get AZ storage account so we can get a list of available storage accounts. Now I'm interested in one by the name of store account HQ1, which is in the HQ resource group. Okay, next thing I'm going to do is I'm going to create a context variable. I'm going to call it $CTX. Remember, PowerShell variables are always prefixed with a $sign when you set their value and also when you call upon it. And I'm going to store the result of running get-az storage account resource group is HQ in this case, name is store account HQ. And the name is store account HQ1. And I'll press enter. So I'll type $CTX so we can see what's in the variable. So what we basically have with that variable is a pointer to that storage account. It will facilitate future commands that we enter that require the name of the storage account in the resource group. We can just refer to the $CTX variable appropriately. But to take it a step further, I'm going to run $CTX equals $CTX so itself, but more specifically, I want to store only the .context property in the $CTX variable. So now if we run $CTX, okay, now we've got all the endpoints that actually point to that storage account, such as for blobs. Now we're ready to go. Okay, now I'm going to run new-az storage container because I want to build a blob container in the storage account and then I'll upload a file into that blob container. So -name, I want to call this HQ budgets. So I'll put that in quotes, lowercase letters. Now instead of specifying the storage account name and the resource group to create that container in, I'll just pass it my context variable. So -context $CTX and I'll press enter. Okay, so we've created our storage account. If I were to minimize Cloud Shell, for instance, and go into that storage account and down under data storage, let's say click on containers, we now have a container by the name of HQ budgets. Of course, if I click on it, it's empty, but it won't be for long. Let's go back to Cloud Shell. Now I'll clear the screen and do a dir. So we've got our file here, budget1.txt. So I'm going to run set-az storage blob content. And it doesn't matter if you use upper, lowercase, or mixed case letters when it comes to the names of commandlets. -file, I'm going to put in double quotes, /budget1.txt, and I'll close the double quotes, -container. In quotes, I'll put HQ budgets, -blob. Well, I want the blob to also be called budget1.txt. And finally, -context $CTX. Notice when I do that, it says it can't find the file. The reason is because if I do a dir, it starts with a capital B here, and we're referring to a file with a lowercase b. So if I use the up arrow key to go back to that previous command, if we refer to our file with a capital B and then press enter, this time it likes it. So bear in mind, there were some cases where case sensitivity is an issue, even in PowerShell. Okay, so it looks like it uploaded it. If we were to minimize Cloud Shell and go back into the portal, and let's say open up HQ budgets, then the budget1.txt file would show here. Now we can also verify that information here from PowerShell. We can also verify that information back in PowerShell with get-az storage container -name, it's called HQ budgets -context $CTX. I'm going to pipe that to get-az storage blob, and I'm going to pipe that to select because all I want to see is the name of the uploaded items in that HQ budgets blob container. And of course, it returns budget1.txt. You can use the Azure CLI to upload blobs into a storage account. So we can also do that in many other ways, like using the Azure Storage Explorer GUI tool. We could use the portal itself. We could use PowerShell, but here the focus is going to be on using the CLI. So what I'm going to do here in the portal is I'm going to launch Cloud Shell. I can get the CLI from there. I'll just maximize the window. And the first order of business will be to get some files in Cloud Shell, because Cloud Shell uses a storage account under the hood. We need to get the files there so that we can then upload them to a storage account. Now, if I just clear the screen here in Cloud Shell and do a dir, it will show me any files I have. For example, I've got a file here called budget1, but I've got some additional files I'd like to upload, and I can do that here in Cloud Shell with the upload and download button up at the top. So I'm going to click that button, and I'm going to click upload. And I'm just going to go ahead and upload a couple of sample files here, so we've got a few things to work with. So bottom right, I've got a successful completion message for uploading, so if I just do a dir, I've got a couple of budget files, budget 1, txt, budget 2, txt, and budget 3, txt. Okay, so I'm going to clear the screen with CLS, and I'm going to start here with AZ storage account list. I want to get a list of storage accounts, but I'm going to add -- query space open close square bracket dot name, because I want to see the names of the storage accounts. Okay, so I've got one here called store account HQ1. That's the one I'm primarily interested in. So I'm going to clear the screen, and I'm going to run AZ storage account keys list. I want to retrieve the keys for the storage account. Remember, every storage account has 2 of these keys. So -- name, well, it's called store account HQ1 -- resource -- group. In this case, it's a resource group called HQ, and then -- output -- table. Oh, looks like I have a syntax error. It should be -- output and then space table. My mistake. No problem. Clear screen. Use the up arrow key to bring that up and correct the problem. There we go. Okay, so now we have the storage keys, key 1 and key 2 shown here. It's wrapping over to the second line. Remember that in a storage account, an access key gives you full access to everything in the storage account. So I'm going to go ahead and highlight and copy by pressing Control C, key number 1. It could just as well have been key number 2. It doesn't really matter. So I'm going to make a couple of variables that contain things like the storage account name and also the key that I've just copied, so we can use those variables to facilitate future commands. So I'm going to go ahead and create a variable here called Azure _storage _account equals, and I'm going to put in double quotes the name of our storage account, store account HQ1, and I'll just correct the spelling of the word storage in my variable name. Okay, I'll press enter. Now notice here, I'm getting an error message. Now, we are not really dealing here, or we don't want to deal with PowerShell variables where you need a $sign in front of it. I want to have more of a Linux or Unix style bash environment. So what I'm going to do then is I'm going to switch from PowerShell to bash, and I'll choose confirm. And we're going to try the same thing again, meaning I'm going to create the variable Azure _storage _account equals, and double quotes the name of it. But this time what's different is we're in a bash shell, not in a PowerShell environment. Let's press enter. No error this time. And that's one of the primary differences. I mean, there are others, but between using bash versus PowerShell here in Cloud Shell, how things like variables are treated, very important. So if I were to say echo $, and I'll put in the name of our variable, Azure _storage _account, and press enter, it returns back what's stored in that variable, which is the name of our storage account. Perfect. Let's do the same type of thing for the storage account key. So I'm going to create a variable here, Azure _storage, let's say access _key equals, and in double quotes, I'm just going to paste in here what I copied from earlier when we viewed the storage account access keys. I'm going to press enter. Of course, I could run echo $, and then the name of my variable, Azure storage access _key. So we use a $sign when we want to refer to what's stored in the variable here in a bash shell environment. Okay, so we've got the storage account name in a variable, we've got the storage account access key in a variable. Okay, so now what I want to do is create a blob container in my storage account. So to do that, I'm going to run AZ storage container create -- name. I'm going to specify here east region -- account - name, which is the name of the storage account in which I want to create this. I'm going to refer to my variable $, Azure _storage _account. And then I'll use the -- account - key parameter, and for its value, I'll just refer to my $, Azure _storage _access _ key variable, and I'll press enter. It returns back created true. So just for fun, let's say in the portal, I'll just minimize the Cloud Shell. If I were to go to my storage accounts view and open up that storage account, go down under data storage containers, we now have a east region container. And of course, if I click on it, it's empty, at least for now. Let's go back to the CLI. I'm going to run AZ storage blob upload -- container - name. Well, we just created a blob container called east region, so I'll refer to that by name. -- name. This is the name of the file that we're uploading, the blob, the binary large object. That means what we want it to appear as in the storage account. I want it to appear as budget2.txt with a lowercase b. Then -- file, we have to refer to the file that we want to upload. Well, that's here in Cloud Shell in the current directory, so / for current directory, and the file is called budget2.txt with a capital B. But we've not yet specified the name of the storage account into which we want this to be uploaded. So -- account - name, we've got a variable, $ Azure storage account. Same goes for the storage account access key, which will give us permission to write to the storage account. I'll specify that with the -- account - key parameter, and as the value, I'll just use our variable Azure storage access key. I'll press enter. Okay, this is good. Having all this JSON output returned to us implies that it successfully uploaded the file. It says finished, and we've got 100% shown at the top of the output here. And if I were to minimize Cloud Shell and go check it out here in the portal, go into the east region blob container, then we would have our budget2.txt file. Let's go back into the CLI, because from here, we can also check our work at the command line. We can run AZ storage blob list -- account - key. So I have permission to go to a storage account. Of course, I'll reference our variable -- account - name. Again, I'll reference our variable -- container - name. So I want to list the blobs only within a specific container within this storage account. It was called, of course, east region, and I only want to see the names of the blobs or the files. So -- query space open close bracket square bracket to be specific .name. Okay, let's press enter. So it returns back that we've got one blob in that newly created blob container, and the name of the blob is budget2.txt. The Azure Storage Explorer tool is a free download from Microsoft. It's a GUI tool that you can use to make a connection to a storage account, and then you can manage the objects in that storage account. So for example, you might use an Azure account, so the credentials to sign into Azure as your way of connecting Storage Explorer to your storage account, or you might just use a storage account access key to gain access to the full storage account. You might have a shared access signature, a SAS, which gives you limited access to the storage account, or maybe even limited access to a single blob. There are many ways that we can make a connection from Storage Explorer to the storage account. It's an alternate way to allow people to manage objects in the storage account, whether it's blobs, whether it's message queues, and so on, without giving them access to the Azure portal. So here, I've gone to the azure.microsoft.com website, and I've searched for Storage Explorer. We can select the operating system on which we want to run it, be it Windows, Mac OS, or Linux-based, and we can choose to download it. I've already downloaded and installed the Storage Explorer, so I'm going to go ahead and launch it from my start menu. Okay, so once I've launched it, the first thing I have to think about is how I will make the connection to the storage account. So I can go ahead and click on the icon of the person in the left-hand navigator, where I could choose to add an account. When I do that, I can specify which type of Azure resource I want to connect to, whether it's the subscription, or a specific storage account, or a blob container, or a file share, or a queue, or a table within the storage account, or even a local storage emulator, which runs locally on my on-premises computer, which can be used for testing purposes. I'm going to click cancel because I can also click on the plug icon in the left-hand navigator, which implies connect, and I'll get to the exact same screen. So for example, I want to choose storage account or service, and I have the option of connecting with a connection string, shared access signature, or a SAS URL, or the account name and key. I'm going to choose account name and key, and I'll click next. And so back here in the portal, I'm going to open up my list of storage accounts. The one I'm interested in is called Store Account HQ1. If I click on it to open it up, I can scroll down on the left, and under Security Networking, I can click Access Keys. I can use either access key, so if I click Show Keys, we've got key 1 and key 2, we've got the key in the connection string. I'd like to use a key, so I'm going to copy key number 1 to the clipboard. Back here in Azure Storage Explorer, for the display name, I'll call it Store Account HQ1. Of course, that's also the storage account name itself, and I'll paste in the account key, and I'll click Next, and then I'll click Connect. So over on the right, in the bottom section under activities, it says it successfully added the new connection. Perfect. Well, if I go to the Explorer, so if I click the topmost icon on the left-hand navigator, I can drill down under storage accounts, specifically under what I named it, store account HQ1, and in parentheses, it implies that I connected with the storage account access key, which I did. So I'm going to expand that. And from here, I can go into blob containers and drill down under there, and I can begin working with the contents of the storage account. For example, I want to create a blob container called West Region. So I could right-click on blob containers. I could choose Create Blob Container. Let's say we call it West Region, press enter, there's West Region. At this point, if I wanted to upload some blobs into the West Region blob container, I could click the Upload button over on the right. I could choose to upload a folder or files, I'll just choose Upload Files. And on the Upload File screen, I'll click the selector icon to the far right, and I'll choose a couple of on-prem sample files. Then I can specify whether they should be uploaded and stored as block blobs, which is the normal option for standard files, or page blob for large files with random read and write access through the file. That would be something you would do if you were uploading a large VHDX file, virtual machine disk file. Or for log files, you could specify it was an append blob. I'll leave it on block blob. The access tier, let's say, is cool. Let's say these files are not designed to be accessed frequently, but yet I still want them stored in the storage account. And I could have key value pairs in terms of tags applied to the uploaded files. And maybe I'll add region, and the value will be West. Okay, I'll click upload. You can always track what's happening in the activity section over on the right. So it successfully transferred our files into the cloud, and they're showing up now in the West Region blob container. Of course, I could click on any one of those files, and it will open it up. In this case, in whatever file is associated with the file extension on my local machine. TXT files on my machine are associated with Notepad, so it opens up and shows me the contents of that file. But I can also right-click on that file and do a number of things. I could download it, delete it, maybe copy the URL if I need a URL reference to that file in that blob container. I could change the access tier. Currently it's cool, but I could switch it to either hot for frequently accessed data on solid state drive storage, or archive for long-term storage, but I'll cancel out of that. When I right-click, I could also get a shared access signature for that individual blob. I could acquire a lease on it, which prevents it from being modified. I could create a snapshot of it, edit the tags, view the properties, so many things to do. We also have a number of buttons up at the top that allow us to do many of those same things as well. Now notice as you start navigating through blob containers in this case that it's opening up separate windows at the top, so you can go ahead and just click the X to close those when you're finished with them. And ultimately, if you no longer need to be connected to that storage account in the left-hand Explorer navigator, you could right-click on it and choose Detach. You then ask, are you sure you want to detach? I'll choose yes, and we no longer have a connection to the storage account. There are many ways that we can manage blobs by getting files into a storage account or downloading them or copying them between storage accounts. We can use the portal, we can use PowerShell, the CLI, and now we've got yet another option, the free AZ copy command line tool. Here I've navigated to docs.microsoft.com, where we have some documentation on how to use the AZ copy command line tool. We're not here for the documentation, we're here because further down we have links for downloading AZ copy. The Windows 64 and 32-bit platforms, it's a zip file that you can extract. For Linux, it's a tar or a tape archive file, and macOS zip file. I've already downloaded and unzipped that tool. It results in two files, one called azcopy.exe, the other called notice.txt. We're interested primarily, of course, in the binary executable program for AZ copy. I'm just going to go back in the file system hierarchy here and right-click on the extraction folder, and I'm going to choose Open PowerShell window here. That'll put me in a command prompt in that part of the file system hierarchy where, if I type dir for directory, we see those same files. The thing to remember about PowerShell, though, is that unlike a regular Windows command prompt, even though you're in the same directory with an executable, you can't refer to it solely by its name. Meaning, if I type in just azcopy.exe, really the same thing, it's not going to be found. And that's because in PowerShell, we have to give it the path, or we can add this file system location to our system path, whatever the case might be. In other words, I could run // which means local current working directory. Then I can refer to azcopy, or if you want to put the .exe at the end of it, that's fine too. Now it knows what we're talking about. However, what we want to do is we want to authenticate to Azure using AZ copy. And there are a couple of ways of doing that. One way to do that is to use AZ copy login --tenant -ID, and I need to specify the tenant ID of my Azure AD tenant, the one I'm authenticating against. Of course, it will then take it further where I have to sign in with an Azure AD user account. There are ways you can also use managed identities and so on to authenticate. So here in the portal, I'm going to navigate to my Azure AD tenant because when you're on the overview blade or page, you can see the tenant ID here. You can actually click the copy icon to copy it to the clipboard. Now that I've done that, I'm going to paste it back here in my AZ copy login command, and I'm going to press enter. Now, of course, once again, if you don't specify // it's not going to find that command. We're going to go to the beginning of the command, and we're just going to add // and this time it works. So we get a message that says, okay, navigate to this URL, which I will copy, and enter the code shown here. So I've navigated to that URL, and I will enter the code, and I'll click next. Now at this point, we have to pick an account we want to sign in with. I've got a couple of accounts here already signed into my browser, or I could use another account. I'm going to select Cody Blackwell. It says, are you trying to sign into Azure Storage AZ copy? I am. So I will click continue. Then it says you've signed in, you're good to go. But there is something else we must consider, and that is role-based access control permissions, RBAC permissions. Here's what I mean. Let's go back to our Azure portal, and I'm going to view my storage accounts. Now the storage account I want to get blobs into using AZ copy is called store account HQ1. I'm going to click on it. So if I go to containers, for example, we've got a container called East Region. That's going to be our focal point. But what I'm interested in are the permissions to work with blobs in this storage account. And we can determine how that works by going to access control IAM on the left. I'm going to click add and add a role assignment. Now we have a number of roles here. The one I'm primarily interested in here right now is the storage blob data contributor role, okay, for full read and write access to blobs. I'll click next. I'm going to select members. Now, in our case, we've signed in with user Cody. So I'm going to add Cody Blackwell here to make sure he has those permissions. And I will just click review and assign. And now if I go to view my role assignments, I can filter, for example, by username. I'll put in Cody. And sure enough, Cody has the storage blob data contributor role. Okay, so back at the command prompt, our login has succeeded. So what we want to do is we want to try to upload a local blob into our Azure storage account, specifically in the East Region blob container that we saw. If I do a dir of .. press enter, we go back one level in the hierarchy to see what we have there. So one level back in the hierarchy, so in other words, in C:\TMP, we've got a couple of sample project files, one of which is called project a.txt. That's the file that I'm going to test uploading to my storage account using the AZ copy tool. The way we're going to do that is we're going to call upon /AZ copy, followed by a space and the word copy and another space. Then in single quotes, I'm going to specify the local on-premises file. You can also do entire folders, but here I'll do one file. And this is what I want to upload into my storage account. So // so back one level in the file system hierarchy, file is called project _a.txt to be specific. Then a space, and the next parameter in single quotes is where I want to upload this to. Now I've got a URL specified here, something about my storage account name .blob.core.windows.net. That's the primary endpoint for my storage account. Back here in the portal, if you open up the properties of a storage account, and if you scroll down on the left-hand navigator, all the way down to the point where you can click endpoints under the settings section, then that's where you'll have access to the primary endpoint for the blob service, and here it is here. So this is what I've copied as part of my command line syntax. what I have added to it. At the end of it, I added /east region because that's a blob container in which I want to upload this local file, and then a slash after that, and the name of the file as I want it to be in the storage account. In this case, all lowercase, project_a.txt, and then I close the single quote. Let's press enter. Okay, so we have all kinds of information here. It authenticated through Azure AD. Naturally, if you have any failed or skipped transfers, you're going to want to make sure you take a look at any error messages that might have popped up, because usually you'll see them, and then deal with them accordingly. Back here in the portal, in the storage account properties, why don't we navigate to our blob containers? Why don't we open up East region? And sure enough, here we've got our newly uploaded file, project_a.txt. When the blob soft delete feature is enabled at the storage account level, it means that when you delete a blob, regardless of how you delete it, it gets marked as being soft deleted. And there's an interval where you can still restore that deleted blob before it's purged permanently. Let's take a look at this. If I were to go to my list of storage accounts and open up an existing storage account, if I scroll down the left-hand navigator, you're going to find options related to things like soft delete for blobs way down under the data management section, specifically on the data protection page or blade. Here we've got the enable soft delete for blobs option, which is turned on. And that's turned on automatically when you create a new storage account. Notice the default interval here is 7 days. Keep deleted blobs for 7 days, after which the blob is purged permanently. You can't restore it anymore, at least not using this mechanism. You'd have to have a backup solution in place to go beyond 7 days. Notice we can also enable soft delete for blob containers, and it has the same retention interval by default of 7 days, after which it's purged permanently. Okay, so let's experiment with this a little bit. In the storage account, why don't we scroll up on the left and go under our blob containers, let's say into projects. Now, first of all, if I attempt to delete project a.txt, this is a blob I've got here, if I were to click delete, so when you're deleting a blob and any snapshots that might exist for that blob, a snapshot being a point-in-time picture of the content of that blob, then not only is the original blob marked as being soft deleted, but so are all of its snapshots. So if I were to go ahead and say also delete blob snapshots, click on OK, project A is deleted. If I look at my notification bell icon on the upper right, it successfully deleted the blob. Now let's go ahead and right-click on project B. It's another blob file I have here. Let's choose create snapshot. And in my notification bell icon, it says it successfully created that blob snapshot. So if I were to click on project B to open up its properties, I can go to the snapshots view to see any snapshots that might exist for that blob. So if I were to try to delete project B, so I'll select it, click delete, notice that the also delete blob snapshots option is automatically turned on because they exist. So I'm going to go ahead and click OK, and as you might expect, it's gone. Now because we've got the blob soft delete feature on, of course it means we can restore it deleted within the last 7 days. Notice that we've got a little slider option here to show deleted blobs. It's currently turned off. If I turn it on, then the deleted blobs show up in the list now. And they show up with the status of deleted. There's no mistaking it when you view it in the GUI. If I were to click on, let's say, project A, which is a deleted blob, notice that I don't have all the tabs at the top, such as edit. All I have is overview, versions, and snapshots. So if I close that out and open up a blob that hasn't been deleted, you've got more than just overview, versions, and snapshots. You've got edit, you've got generate SAS, you generate a shared access signature for that blob. Okay, so I can right-click on that deleted blob and I can choose undelete. When I do that, it now shows up as active. And of course, as you might guess, if I click on that blob to open up its properties, we've got all of the tabs across the top, including edit, where we can actually get to the actual data. In this case, it's a text file, so we can do that directly here in the browser. Otherwise, you might be prompted to download the file. I'll click the X to close out of that. Let's do the same thing for project B. Let's right-click on it and undelete it. When I do that, if I click on project B, not only was it undeleted, so I can click edit to get to its contents, but if I go to the snapshots tab, also the snapshots were undeleted along with it. So this is a great safety net, I guess you could call it, in that if you mistakenly make changes, if you mistakenly delete blobs, whether programmatically or through the GUI, you've got an alternative method by which you can restore them for up to 7 days by default. You can increase that retention period if you so choose. You can set the maximum retention period. If we go back and check out that setting here in the storage account data protection properties, the default is 7, but you can set that to a maximum of 365 days. Click save to put that into effect. And also, don't forget that part of the strategy here for protecting things from deletion can also include soft delete for containers, which is 7 days. The difference being that you can restore a deleted container and all of its blob contents for up to 7 days if something happens. Now that's on by default, so let's try it out. Let's go back up into our blob containers. I'm going to click HQ budgets where I've got a budget file. That'll be our example. So I'm going to select HQ budgets and I'm going to choose to delete the container. I'll click OK, and after a moment, it's done, it's gone. If we open up our notification bell icon, it says it successfully deleted the container, which of course means any blobs within that container. If I choose the show deleted containers button, HQ budgets shows here as having been deleted. And if I click on it, there's not really much I can do in here because it's in a deleted state. However, I can restore it. If I select HQ budgets, right click on it, and I can choose undelete. I'll go ahead and do that by clicking save. And as you might expect, HQ budgets now shows up. This time when I click on it, there's a lot more because we can view the contents of it like the budget1.txt file. In this demonstration, I'm going to show you how you can enable and work with blob versioning. Blob versioning is one of those features that you would find in many document management systems, such as SharePoint Server. It's been around for a long time. It allows you to automatically have a copy of changes to a file. So if you have a file in a storage account and then it gets modified, well, when it's modified, that becomes the current version, but its previous state becomes a previous version that you can go back and view, you can download it, you can maybe make that the new current version. That can be helpful if you or somebody has mistakenly overwritten a certain version of a file, or a certain version of the file has become corrupt. And that's not to say that you shouldn't still perform backups. You still need to use an alternate backup solution for safekeeping. But versioning is very handy nonetheless. So let's examine number one, where this is turned on or off if you want to disable it if it's been turned on, and also how it works. So let's start by going into our list of storage accounts. I'm going to open up an existing storage account. And what I want to do is go all the way down on the left under data management and into data protection. So we have a couple of other familiar items here like enabling soft delete for blobs, enabling soft delete for containers, and further down I can enable versioning for blobs. Turn that on. And all I have to do is click save. Now the idea is that versioning applies from this point forward. So for any blobs that you modify, it will save what you had opened up as a previous version. And if you come and turn this off in the future, there are no more new versions that will be generated, but the existing versions created when it was turned on will remain in the storage account. Let's go and take a look at one of our blob containers up here by clicking containers on the left. I'm going to open up projects. Now you could right click on a specific file and you could create a snapshot of it. And that means that when you click on that file, you can then click on snapshots at the top and have point-in-time pictures, if you will, of the state of that file. Now the reason I bring this up is because you might wonder, well, what's the difference between a snapshot and versioning? Because what happens is if I open up project A, let's say I could stay there. If I click edit, that's what it says in the file right now. This is project A. Let's just add something here that says change 1, save. Okay, save that change. I close out of there. And when I go into that file, project A, I can view versions. The contents of a blob version is immutable. In other words, it can't be modified, at least not directly. What you could do is you could download that version and then do whatever you wanted to that downloaded version of the blob file. I've got a couple of different previous versions of that file, but then I've also got a snapshot. What on earth is the difference? The difference is that versions are automatic. Whenever you make a modification, whatever you opened up becomes a previous version, and whatever you just saved is the current version. Snapshots are manual, but other than that, they are similar in nature. So if I go back to versions, I can click on a specific date and timestamp that's part of the nomenclature for the version ID. I can click on it to open it up and get some properties about that specific version of that file or that blob. Now over on the far right, I could also click the context menu and I could download a previous version, so whichever one I've got selected. I could make it the current version, I could delete this version, I could even generate a shared access signature for this individual blob version. I could view the version properties, I could even change the access tier, and I could also modify the access policy, such as adding a legal hold policy or a time-based retention policy for just that version of the blob. So for example, I'm going to select one of my previous versions of that file, and I'm going to go ahead and make it the current version. So now, if I click edit, we're back to just this is project A, as opposed to the change that we had added to it. The other thing to think about is that you can also manage this aspect of blobs versioning through lifecycle management, an automated process in the storage account. So if I go back to my storage account, let's say in the left-hand navigator, we go all the way down under data management, that's where we can click on lifecycle management on the left, where I could add one or more rules to automate the lifecycle of items stored in the storage account. So I can add a rule, let's say it applies to all blobs in the storage account, and for the sake of argument, we're just going to call this rule 1. Now I could filter it out so it applies to certain blobs, but what we can do, and the point is this down below, is the rule can apply to not only just the original base blob, in other words, the current version in our context, but also it might apply to snapshots and also versions of a blob. Because that's what we're talking about, isn't it? Versioning. I could click next and say if the base blob itself was modified, let's say more than 90 days ago, then we could choose to move blobs and snapshots and versions of blobs to cool storage or archive them or whatever the case might be. So the key is that we can manage versions of blobs using automated lifecycle management at the storage account level. You can configure immutability settings for an Azure storage account, such as setting a legal hold. When we talk about immutable, what we're really talking about is making sure that something cannot be written to, it can't be modified, and it cannot be deleted. Now, there are two types of immutability settings for a storage account. One is time-based. When you have a time-based retention policy, any existing blobs can be read from the storage account, new blobs can be created, but for blobs that are already there, they can't be modified, nor can they be deleted. Now, if you have a time-based retention policy of 7 days, after 7 days, blobs can be deleted, but they still can't be modified. So time-based retention, then we have legal hold policies. The difference here is that with a legal hold policy, the data is immutable, cannot be modified until you disable the legal hold, when you clear it. But just like a time-based retention policy, when a legal hold is in place, blobs that are there can be read, and you can also create new blobs. You just can't delete or modify them. And if you're working with versioning in a storage account, different versions of blobs, then these settings would also apply to versions. Let's open up an existing storage account here in the portal and check out where this immutability stuff is. So what I'm going to do here in the portal is go into my left-hand navigator for storage accounts. I'm going to open up an existing storage account, and in the left-hand navigator, I'm going to scroll all the way down. Under data management, where I'll then click data protection. This is where we have other options such as whether we want to enable point-in-time restore for blob containers, soft delete for blobs, or soft delete for containers. And if I scroll down towards the bottom, we also have things like version level immutability support. But it's grayed out, and that's because this is one of those types of settings that can only be specified when you create a storage account. This storage account already exists. So let's go back home here in the breadcrumb trail. I'm going to create a resource. It's going to be a new storage account. So I'll click create. I'll deploy it into an existing resource group, and I'll call it store account HQ2. I'll deploy it in East US. I won't change anything else here on the basics page. I'll click next for advanced. And basically, I'm just going to navigate all the way up to data protection. Now, these are the settings we were just looking at within an existing storage account. So you get to specify their settings upon creation of a new storage account. Let's scroll down towards the bottom. This is where we can now enable the option for version level immutability support. So I'm going to turn that on. I don't want to specify anything else. I just want to create the storage account. So I'll click review and create, and then I'll click create again. So now that we have our new storage account, let's go to it. And in its properties, let's go to the same place we did originally, meaning let's go down under the data management section and click data protection. Now, if we check our setting here, if I scroll all the way down, version level immutability is turned on. It is grayed out because remember, you only set this upon creation of the storage account. But because we did enable it, we have a button to manage policies related to immutability. I'm going to click the manage policy button to do just that. And then I'll click the add policy link. So for the time-based retention period, I'll specify 3 days. Now, because append blobs are designed to be added to, such as adding to the end all the time with new log entries to log files, we have the option to allow protected rights to append blobs. But I'm not going to do that. I'm just going to click OK. So we now have our 3-day time-based retention policy showing in the list. However, the state currently is unlocked. If I click the 3 dots, we can choose to lock or to put it in effect to edit any changes, such as the number of days, or delete it. I'm going to choose lock. And it asks me, are you sure you want to do this? Because when you lock the policy, the time-based retention policy, you will not be able to delete the container or any blobs or even the storage account until this time has expired. I'll type in yes, and I'll click OK. So I'm going to close that out. Now let's see, first of all, do we have the ability to create or add a new blob? So I'm going to go to the containers. I'm going to click add container. I'm going to call it South Region. Let's just see if we can create the blob container. Well, there's no problem with that. Remember that the immutability settings are related to modifying existing entries once they're there or deleting them. So I'm going to go into the South Region blob container. I'll click upload. And I'll select a couple of on-premises files I want to upload there, and I'll click the upload button. And sure enough, they upload just fine. So it's business as usual, really. But what happens if I try to make a change? For example, what if I select budget1.txt and I click delete and I click OK? Well, budget1.txt is still showing up in the list despite the fact that I might click refresh over and over and over. If I click on my bell notification icon, it says fail to delete blob. This operation is not permitted as the blob is immutable due to a policy. In our case, the 3 days. After 3 days, then the time-based retention policy will have expired. But we don't have the option of modifying, nor do we have the option of deleting these items until that time-based retention policy has expired. But what's interesting is besides setting a mutability policy at the account level, like we did for the time-based retention, you can also do that for a blob container, or you could set a time-based retention or a legal hold policy for an individual blob. Let's take a look at that. We're going to create a brand new storage account. So I'll click home here in the portal. I'll click create a resource. We'll type in storage account. I'll select that and click create, and I'll deploy it into an existing resource group. I'm going to call this store account central. I'm going to call this store account central. It's going to be deployed in East US. I'm just going to jump ahead here to the data protection part of the configuration where, as we might expect, I'm going to go down and turn on enable version level immutability support. Then I'll click review and create, and I'll click create. I'll click go to resource so we can go into the properties of the storage account. Now let's begin by looking at immutability at the storage account level, meaning we're going to go down under data management once again, data protection, scroll down to the bottom where we can click manage policy. And again, you can add a time-based retention policy. However, let's close that out. Let's go up to the container level and let's add a new container. I'm going to call this container central, and I'll choose create. So we have a central blob container. If I click on the menu selector button to the right of it, I can choose access policy, and I could add an immutable blob storage policy here. Notice it would be time-based retention. Legal hold is grayed out because that would be for individual blobs. So if I go into the central container and let's say we upload a blob, Once we've uploaded that blob, we can right-click on that individual blob, choose Access Policy, and when we go add a policy here, we have the choice of both legal hold and time-based retention. So legal hold, I could choose OK, and the retention is indefinite basically until it's turned off. So now that that's turned on, if I were to delete budget 1, I'll just click OK and refresh, but budget 1 remains. And in my notification area, you can't delete that file. It's immutable due to a legal hold. So if we were to right-click on that file, go to Access Policy, we could then delete the legal hold. And now if I delete that file, by clicking the delete button up at the top and I'll choose OK, it disappears. So the legal hold can be turned on and off. And it's called legal hold because you might be asked for legal reasons, maybe to maintain the preservation of evidence, digital evidence, to make sure it cannot be modified. So you can set a legal hold on blobs. So that's a bit about immutability as it relates to Azure storage accounts. Blobs that are stored in a storage account can have their access tier set. The access tier relates to a couple of items, one of which is how accessible that blob is. In the cool access tier, it's designed for infrequent access, but the hot access tier is designed for frequent fast access because it uses solid-state drive storage in the underlying technology. As its underlying technology. Of course, you then have the archive tier for long-time retention. Let's take a look at how we can manage the access tier for storage blobs using the portal. So to get started here in the portal, I'll go to my list of storage accounts, and I'm interested in a storage account called Store Account HQ1. So I'll click to open that one up. Then I'll navigate down on the left under Data Storage into Containers, where I have a number of blob storage containers. Now notice, if I look at these settings by clicking the menu button on the far right for that blob container, there's not an option to change the tier at the container level. However, if I do open up a specific blob container, I can right-click on an individual blob itself, where I do have the option of changing the tier. Of course, I have a button up here, I don't have to right-click. If I were to select a number of items, notice the Change Tier button grays out, so you do one at a time. So for example, I'll right-click on one of my blobs, and I'll choose Change Tier. Currently, this blob is set to Hot Inferred. Inferred means it picked up that setting for the hot access tier from the storage account's default settings. However, we can also choose the cool access tier. We can also choose the archive access tier. When we do choose archive, it says if you do this, if you set this file to that archive tier, it means the blob is inaccessible. Even though it shows up in here, you won't actually be able to access the contents of that blob file until it gets rehydrated, which could potentially take hours. So if you ever think you're going to need some blobs in a hurry and you can't wait hours to get to their contents, do not move them to the archive tier. In this case, for example, I'm going to switch this to the cool access tier and I'll choose save. So in the access tier column now, in this case, my sample file, project.txt is showing, speaking of the cool access tier, the other two are still in the hot inferred access tier. So you can set the access tier for individual blob. But again, remember that inferred means it picks it up from the storage account settings. And what we're going to do here is we're going to change the default storage account access tier to cool, which will reflect not only in new blobs, but also in existing ones. For example, here in the projects folder, we've got project B and C, which show up as hot inferred. Bear that in mind for a moment. Let's go back to our storage account, where on the left, we want to scroll down and go down under settings configuration. So on the right, what we need to do here is go down to the blob access tier default, which is currently set to hot. Let's set it to cool, and let's click save. Now that means it's a bit slower access. It's using hard disk drives as the underlying technology instead of solid-state drives. But if we were to navigate back to our blob containers projects, notice that project B and C now show as cool inferred. Of course, we could right-click on them and change that tier, let's say to the hot access tier, faster storage for more frequent and low latency access, and then that will be reflected in the access tier column. Let's not forget also, if we go back to the properties of the storage account, if I scroll down on the left, down under data management, in lifecycle management, cloud technicians can add a rule to automatically control the lifecycle of blobs in the account. For example, if I call this rule 1 and click next, we can look at blobs that were modified within a certain number of days, and based on that value, we can delete the blob or move it to a different access tier like cool storage or archive storage. So changing the access tier might be automated then through the use of lifecycle rules. But then there's also ways to manage the storage tier for a blob using command line tools. So for instance, if I were to go into Cloud Shell, and if I were to run git-help, so I'm in PowerShell here, there's a command called set-az storage account, which is used to modify the properties of the storage account. So we might set the storage access tier at this level. So I'm going to ask for -detail. I'll press enter. So if I go up and look through the help screen for this particular commandlet, we have a parameter here called access tier, and the help screen says it specifies the access tier of the storage account, and acceptable values would be hot and cool. Okay, so we could do that at that level. In the same way, if I were to get-help on the set-az storage blob commandlet, and again ask for detail, maybe this time I'll pipe it to more so it stops at the first screenful. So in the same way, if I were to run get-help on set-az storage blob content and ask for -detail, and I'll pipe it to more to stop after the first screenful. So as we are uploading a file as a blob into a storage account, there was a command line parameter for this commandlet called -standard blob tier, where we can specify hot, cool, or archive. So we can set it at the individual blob level. So the point is that we can do this at the command line level as well as in the GUI. As you might imagine, we can also do it using the CLI. Archiving is a very important part of the data lifecycle. When it comes to data lifecycle management, archiving means that we want data to be available, but not immediately available. We want to retain a copy, but we understand that there is a time, but we understand that there is a process, in the case of Azure, called rehydrating, which can sometimes take many hours before archive data is actually accessible. So the archive data will show up in a storage account, we just can't get to the contents of that archive data until it's fully rehydrated. Let's see how that works. We're going to navigate to our storage accounts view here in the portal, and I'm going to open up a storage account called Store Account HQ1. That's our example storage account. I'm going to go to the containers page by clicking on that on the left, and I'm going to open up the East Region blob container on the right. Now we've got a single file here. It's called project A.txt. Notice under the access tier column, it currently reflects that the access tier is cool inferred. Inferred means that it picked up the default storage account setting, which if we navigate back to our storage account, we can view by scrolling down in the left-hand navigator all the way down under settings and then clicking configuration, because this is where we can determine what the default storage tier is. And notice the blob access tier default is set to cool. Okay, well that explains then why we have cool inferred as the current access tier for that project A file. But we can right-click on an existing blob and we can select change tier. We can switch it to the hot tier, which uses solid-state drives under the hood, which provides faster access and also means it results in more cost than using the cool tier, or we could select archive, which is what I'm going to do here. When I select archive, it says if you do this, it makes your blob, at least the contents of the blob, inaccessible until it's fully rehydrated to the hot or the cool tier, which can take many hours. That's fine. So we'll go ahead and click save. Notice that under the access tier column now for that blob, it shows archive. Now normally, if we navigate back to a different blob container and open up a blob, when you open up the properties of the blob, one of the things you can do is edit it. And depending on the type of file, you might be able to edit it and see the contents inline here in the browser, or you might be prompted to download it. Let's do the same type of thing. Let's open up the properties for an archived blob. So when I open up my archive blob in the properties, there are a few things that are unavailable immediately at the top in terms of buttons, such as downloading. And then we have a message that says, well, this blob is currently archived. You can't download it until it's rehydrated. And rehydrating means moving it into an accessible tier, be it hot or cool. If I right-click edit, we just get a request is not authorized type of message because there really is no content here. It's been archived. It's not designed to be accessible. So I'm going to right-click on my archived file, and I'm going to choose change tier. Now we have a date and timestamp when the access tier was last modified, moving into the archive tier. But I'm going to select the cool tier. Now you can set a higher rehydration priority if you want it available more quickly, but you're going to pay a premium for that as opposed to standard. I'll leave it on standard and I'll click save. Now notice that the archive status column reflects that there is a rehydrate pending to cool. How long will that take? We don't know exactly, but it could take hours. So the idea is that we can click refresh to check on the archive status periodically. You'll know that it's done when you actually can open up the file and not only have the option of downloading, but it should remove the message about archiving or rehydrating, in this case, rehydrating. So I'm just going to click the X and bide my time and keep clicking refresh for a few moments. Alright, so after many hours, my project A.txt file now shows having an access tier of cool. So if I actually click to open up that blob, I now have the option of downloading it. There's no message about the blob being rehydrated, and I can also click edit to actually get to the contents of the file. So we have a way then that we can archive files that do not require frequent access, but that we must retain. Now bear in mind that if you don't leave things in the archive tier for at least 180 days, you're going to incur some early charge fees for taking it out of the archive tier. Having said that, I'm going to close out of that, and I'm going to go back to the properties of the storage account because if I scroll down way down on the left and go into data management and choose lifecycle management, this is where we could add rules that could automate the archiving of blobs, given that they meet certain conditions. So for example, if I call this rule 2 and have it apply to all blobs in my storage account, could even apply to snapshots and versions, right in the next, this is where I can determine that after a certain number of days since last modification, that the blob could be archived. And notice here it even mentions that you want to keep the object for 180 days or longer. 180 days is the magic number, as we know, where we will incur fees if we don't leave things in the archive tier that long. So using the portal then to manage archiving is quite straightforward, given that you might have to comply with certain laws and regulations that require the retention of data for a period of time. In this demo, the focus is going to be on how to automate lifecycle activities for blobs in a storage account. Now, of course, you can manage blobs and their lifecycle properties manually. What that means is you might, for example, take a blob that hasn't been modified in a while, and you can manually move it, let's say, from the hot tier to the archive tier. That way you're saving on costs because it's data that really probably doesn't need to be accessed frequently. However, we can also automate that type of activity, and that's where lifecycle management rules kick in. So I'm going to take a look at that. Here in the portal, I'm going to start by, of course, going to our storage accounts view so that I can open up a storage account in question. Now, in the left-hand navigator for that storage account, if I go all the way down under data management, there is a lifecycle management option. So I'm going to click on that. Now, you can have one or more rules that look at blobs, binary large objects, to determine if they should be archived or moved to the cool access tier. But if you think about a blob, a binary large object, let's actually go take a look at one for a moment. If I go to my blob containers here, let's say I open up one that has a blob in it, you can right-click on a blob and change the tier manually as we've stated. Okay, so from hot, cooled, or archived. Of course, if a blob is archived, while it still shows up in here, you can't get to the contents of the blob until it's unarchived or fully rehydrated. That means you're moving it from the archive tier to cool or hot. That's part of lifecycle management that we're going to talk about automating. The other aspect to think about is that when you go into a blob, if versioning is enabled at the storage account level, then you can actually create multiple versions of documents. Actually, you don't create them. It's automatic if it's enabled. So that when you modify a blob, it'll save what is now the current version as a previous version. And the modifications you made and saved, that becomes the current version. So you can revert to the earlier versions. But you can also, instead of having it happen automatically, you could manually create snapshots. Now that would be done by right-clicking on the blob and choosing Create Snapshot. And why am I saying this? Because when we think about automating data lifecycle management with rules, we have to think about if we're interested in only the base blob or the real current version blob versus any versions that might exist for that blob if versioning is enabled, or snapshots of the blobs. That's why we're talking about it. Let's go back to our storage account. Let's once again go down to lifecycle management, but this time we'll take it further by clicking Add a Rule up at the top. I'm going to call this Rule 1. Now the first thing to think about is your lifecycle management rule can be scoped to look at all of the blobs in the entire storage account, and sometimes that will be the case, or you can limit it with filters. Now when you limit it with filters, what happens is you get this filter set part of this configuration that shows up as being step number 3. If we don't do that, step number 3 disappears. Down below, do we want this to apply to block or append blobs or both? And the block subtype, which we just described recently, do you want this to apply to base blobs, snapshots of blobs, versions of blobs? Just turn on the appropriate check marks. Then I would click Next and determine what I want to use as my criteria. For example, if base blobs, so not snapshots, not versions, but if the actual base blob itself is modified within a certain number of days, let's say 90 days, we can then determine what we want to do. And this is automated. Do you want to delete the blob? That's a scary proposition, but depending on the nature of how you're using the storage account, that could make sense sometimes. Or from the drop-down list, we could choose to move the blob to cool storage. Cool storage uses magnetic hard disk drives, which ends up being cheaper than hot storage, which uses solid-state drives. Or, of course, we could choose to move to archive storage. It then says down below, if you need to read the contents of a blob on a consistent basis, you don't want to archive it, because blobs that are in archive mode must first be rehydrated, which can take many hours, which means moving them to hot or cool tiers before you can actually get to the contents of the blobs themselves. So I'm just going to say move to cool storage. In this case, I'll click Next. Now, because we turned on filtering, we're in step 3 for filter set, where we could enter a prefix or a file path within the storage account, the one that we're doing this configuration in. We could fill that data in, or we could also base our filter set on tag items, so key and value pairs. However, I'm just going to go back to the first step and say apply the rule to all blobs in the storage account, and I'll just add the rule. So rule 1 is now added. It's showing with a status of enabled. Of course, we could select it and disable it if perhaps we only created it, but we don't want it in effect yet, or if there's some kind of a problem with it, we might disable it as opposed to deleting it. And the next question I would have is, how often are these rules evaluated or applied against what's in the storage account? The answer is once every 24 hours. So we can take up to 24 hours before any of the actions in your rules are taken against matching blobs. The other thing to think about is that you can add multiple rules. What if I have more than one rule with different actions that apply to an individual blob? Which of the actions would be applied? The answer is the cheapest one. So if you have a rule that is set to move blobs after a certain period of time to the cool tier versus deleting, then deleting is going to happen because it's cheaper. Now that might not be desirable, so you need to think very carefully and plan out the interaction between multiple rules that could apply to blobs. So in this course, we've examined how to manage storage account blobs using various tools. We did this by exploring how to create an Azure storage account and then how to upload blobs using the portal, the CLI, and PowerShell. Then we learned how to manage blobs with Azure Storage Explorer and how to copy blobs using AZ Copy. Next, we managed the blob soft delete feature and worked with blob versioning and immutable blob storage. We then worked with blob storage tiers, data archiving, and automating storage account blob lifecycle activities. In our next course, we'll move on to explore how to limit access to a storage account.